For Mark Solo, today was to be both a good day and a nightmare. As head of global IT at Amdo Bank, he always had challenges. But for the last month, Mark has been wrestling with the IT implications of acquiring a major American bank. Today, Mark could either turn a dream into a reality or lose his job.
Look, Mark, I need to make a decision today. I know your health isn't good, but quite frankly, with the money that I'm paying you, no, I don't care. I have a board meeting at 7 this evening, assuming everyone can make it in through the floods, and the purchase of Interstate Bank must be made within the next 48 hours. And I need you to tell me which way to go with the IT integration. Where are we?
The internal IT services and software architecture at Interstate are good and are nearly as big as ours. At the moment, as you know, their whole setup is incompatible with mine. Sorry, Amdo's. Our own internal IT architecture is the best in the world, and I'm not going to allow it to be corrupted by another inferior system.
Oh, why can't we just dump their system and merge it with ours?
Horrendous time implications and a huge cost to us.
We'll just have to incorporate that into the deal. Are you sure that there's no one else that can give us an alternative view?
No. I'll sort it.
I need the answer with backup documentation by 6 tonight.
Normally, Mark needs to address his type 1 diabetes condition twice a day, but because today is far from normal, he only just manages to do it, before taking a moment to stabilise. Surely that's blown his chances, you may think. Or maybe this brief moment out of time might help him find his answer. Mark Solo's day was about to be the most memorable of 2008. 2030, actually.
It's awesome. Who are you?
I'm called Crystal. This is one of many IT systems that uses GRID middleware to aggregate and share sizes of data and information that you guys, back in 2008, could only dream about.
Well, I think we have a pretty good idea of what's coming.
That's what the early supercomputer geeks thought. But within about 7 years, they had developed the personal mobile with more power in it. It's hard to predict the future. But we can invent it.
So show me the IT world of 2030 then.
No. Let 2 citizens of Europe show you. Marcel? Susan? What would you like to see?
Something about integrated data and computing in 2030.
Everything in 2030 is about integration. All of our systems no longer just store data or perform basic integration. We have an entirely collaborative culture on a global scale. And it's completely invisible to users, just like your internet was in 2008.
Go on.
Give us an example from your news today.
Okay. Sudden flooding.
Marcel? That's one for you, I think. He lives near one of Europe's biggest rivers, the Rhine. Marcel?
Sure. Come with me. I live on the Rhine. 6 countries have this huge river flowing through them, and therefore, if climatic effects become too severe, well, the threat to millions of Europeans has, well, in the past, worried many scientists and governments.
I read something about grid networks and floods not long ago.
The solution we now use in 2030 was first developed back in 2002.
How's it work?
The first thing they did was to build middleware for a grid of computers that integrated millions of pieces of weather forecast data with detailed mapping of the whole landscape alongside the river. A large number of collaborators fed into the grid every conceivable element of information, like wind conditions, time of year, rainfall, temperatures, and citizens' daily activity patterns. Once this had been achieved, it was possible to enter many different scenarios and allow the collaborative grid to predict precisely what might happen in any emerging condition.
And then?
We needed to prepare emergency services for these scenarios. By transferring much of the results from the collaborative grid simulation into a graphical virtual reality system, it became possible to simulate each scenario at a physical point on the Rhine. Emergency response teams now regularly visit their own virtual environment and witness how each scenario will affect the geographical location. These are now stored within a global environmental prediction system, and when real conditions began to develop, the local teams input the current data and the predictive system allows them to plan their response virtually.